Great. Well, my name is J.R. Logan. I am the executive director of MakeHaven, and I'm really happy to see folks from across New Haven, from our sister makerspace in Hartford, and from beyond. And I'm looking forward to a rich conversation about how we can use the Internet of Things and how we can implement a citywide network. This conversation is really starting with how that happens in New Haven, but it's certainly applicable more widely. And with that, I want to introduce John Fitzpatrick, who has been diligent in researching this technology, has a much better handle on it all, and he will do a better job of introducing his own background, interest, and how he came to this technology. John?
Thanks, JR. I'm going to share my screen. Okay. Okay. I'm going to be talking today about an Internet of Things company called Helium. They are building a network for the Internet of Things, and they want us to help them do it. And an explanation of that will become clear as I go through the event. Let me talk a little bit about myself and my Internet of Things credentials. I co-founded an Internet of Things startup and acted as its CEO from concept to exit. We built a combined hardware-software system that connected the glucose meters used by people with diabetes to measure their blood sugar, so that those blood sugar measurements would get off of the glucose meter and online, where they could be put to better use. I also managed the IoT system at Yale New Haven Health. This is a system spread across 4 hospitals, 2 here in New Haven, 1 in Greenwich and 1 in Bridgeport. There were 10,000 pieces of hospital equipment that had Wi-Fi trackers on them, and we could watch and track as those pieces of equipment moved around hospitals and see where they were used, where they were needed, where they shouldn't be. There were also 3,000 Wi-Fi thermometers in refrigerators, freezers, operating rooms, storage rooms, measuring temperatures and monitoring temperatures to make sure they stayed in the proper range. I think I'd also call myself an IoT industry observer. I track about 150 IoT companies. And also I have no relationship with the company Helium. I'm not an employee, I'm not a contractor, I'm not being paid for this talk, I'm not being given any equipment for this talk or discounts on this talk. As an owner of one of their pieces of equipment, I do stand to benefit if other people in New Haven buy these, because my equipment will earn me more if that happens. But that's the only sense in which I benefit from giving this talk. I did see that somebody from Helium, Travis Teague, has joined the call, joined the session, and I've been in touch with Travis before, and if he can add or correct anything I'm saying, he's free to jump in. Thanks for that help, Travis. Okay, so this is what I'm going to be talking about. First, the IoT problem that Helium is trying to solve, and then the way that Helium is trying to solve it, and the factors that should go into your decision about buying a Helium hotspot, the risks and the rewards, and the current status of the Helium network and the overall Helium project. That's going to run about 15 to 20 minutes, and I'm going to throw it open to questions from there. I'm consciously avoiding getting deep into the technology because that could lose you. It's a complicated, involved, very rich, and very interesting system, but I think I'm going to let the explanations of that be driven by the questions that you ask. After we do questions for a bit, we're going to go off on a bit of a tangent to talk about a new project called HardShare, which is a sandbox for IoT makers, for inventors, to make it easier to develop IoT devices. And then if there's time left over, I do have a few slides regarding the technical details of of how the system works, how it's governed, and some online tools that you can use to look at them. Okay. How did I come to be interested in this, and how did I learn about Helium? About 3 years ago, I started thinking of another startup idea. The idea was to build a device that you would attach to street signs. And this device would detect when they get knocked over and notify the city, the state, whatever government, so that they could be put back up. And you know, in the case of a stop sign, this could prevent an accident. It could save somebody's life. And I did that full time the first half of last year, and I did it with a partner, Joe Transu, who is on this call. And we were looking at, you know, what would it cost to develop this kind of device? What would it cost to manufacture it? What would it cost to connect it? So we looked pretty closely at the available connectivity options, and we found that, you know, it's not really a mature, the mature capabilities aren't there yet. There are options. They're not perfect. They're not widespread. And it's certainly a problem that still needs to be solved. Now, this might make you curious. I mean, you're walking around with your phone all the time and you have perfectly good coverage. These sorts of devices need a different type of coverage. The type of coverage that your phone uses consumes a lot of power, and you can't charge up a device like this every day. In fact, you want it to go. You might want it to go for years without having a battery change. You might want the battery to outlast the device. Say you change the devices every 5 years. You might want that to be the only time you actually touch these, because there will be so many of them and they'll be so spread out. And also the connectivity that phones require is just too expensive for these kind of devices. You wouldn't be spending $15 a month to connect them. There's a name for these kinds of networks. They're called low power wide area networks, or LPWANs. They need certain requirements. They need to be low power, they need to be long range, and they need to be expensive. What they do not need to be is high data rate or high bandwidth. And they don't need to be low latency either. If you're going to send, say, a temperature up to the web, up to the internet, if it takes a second to get started, that's really not a big deal. You know, with certain applications, maybe online gaming, a second would make it undoable. But here, you don't need low latency. And that figure there shows where the various wireless technologies fall on the axes of bandwidth and range. In the top left, you see 802.11. That's Wi-Fi. That's got high bandwidth, but not real long range. 100 feet maybe. And then a little to the right, you can see 4G that we're connecting our phones with. Longer range, still high bandwidth. And then in the bottom right, you've got LPWAN with long range and low bandwidth. So that's what's needed for IoT devices that are going to be moving about in the greater world, or not moving about, just installed in a fixed location in the greater world. There are current options for this. The big carriers, the big telcos, have implemented a standard protocol, two of them actually, NB-IoT and LTE-M, also known as CAT-M, that are lower bandwidth and lower power. These, all three of the major US carriers have done this. They have not gotten a lot of traction on this. They've been implemented in other places, but it's sort of the same situation. In fact, one of the carriers in Japan, NTT Docomo, launched its NB-IoT network last April, and they shut it down this past March, so it didn't even survive a year. NB-IoT is used somewhat well in China, but this is not by any means a dominant player. You might think that it would be easy because the cellular carriers already have all the infrastructure out there, but that's not the case. Sigfox is a traditional carrier in the sense that they are installing towers and gateways and coverage, but they're doing it specifically for the Internet of Things and in order to build an LPWAN. In fact, that's reflected in the way they call themselves the 0G network. 3G got faster, became 4G, and then 5G is supposed to be faster than that. They're not looking to be fast at all. They're looking to be 0G. LoRa is the third option. That's the one we're going to be most interested in today because Helium works with LoRa. And that is a different model entirely from the way the big carriers are doing it and the way Sigfox is doing it. Here's a look at the LoRa ecosystem. So the IP, the intellectual property for LoRa, is owned by a company, a chip manufacturer called Semtech. And they make the chips, or they license the technology to other people to make the chips. And every time the chip gets made and gets sold, they collect royalties on that. And that's their business model. Their business model isn't to provide connectivity and charge you per device or per byte that gets transmitted. It's to sell these chips, and they're leaving the build out of the network to other players. There are players building the hardware, the gateways to do that, and then there are players building out networks for that. You can see that Comcast has gotten into this and built out the network, which includes both the hardware and the back end that has to be in place to get the data where it's supposed to go. And that last one, the Things Network, is actually free to use. And it's great for developing devices, great for tinkerers, great for hobbyists. But there's a problem with these. And you could call it a chicken and egg problem. You could call it a catch-22 problem. Nobody's going to build devices unless there is a substantial, widespread network in place. And if there's no network in place, nobody's going to build devices because there won't be any way to connect them for their users. Helium calls this the cold start problem, and they're taking a crack at solving it. And here's what they're trying to do. So they've chosen to build a network first, believing that devices will come after that. And what they're trying to do is convince us, everyday people outside of Helium, individuals, to build it for them. They're trying to convince us to pay for the equipment that the network will use, trying to convince us to provide the connectivity for that equipment, to connect it to the internet using our home internet connections that we pay our ISPs for. And how are they trying to convince us to do this? They're trying to convince us to do this by offering us a reward. And that reward is the Helium cryptocurrency, which is called HNT. So how exactly does this work? Well, they sell a device, a box, a gateway for the Internet of Things, and they call it the Helium hotspot. You buy one, you take it out of the box, you plug it in, so you power it with your own electricity. You connect it to your network. You can do this with either Wi-Fi or Ethernet. And then it picks up the transmissions from the Internet of Things devices that are out there in the world, sending locations, sending temperatures, sending air quality, whatever IoT data is out there that needs to be sent. And then the hotspot relays that data to where it needs to go, and you get rewarded with Helium's cryptocurrency. So that's the deal. Now, why would you want to buy one of these things and do this? Maybe because you love cutting edge technology, you want to be the first one on your block, you want to have bragging rights that you were in on this early, maybe because you want to support innovation in New Haven, where I think most of you are from, or wherever your town is, so you can get this network in place so that you can be on the cutting edge of the Internet of Things, so that people will deploy the services for Internet of Things where you live. Or maybe it's because you believe the Helium cryptocurrency will become valuable. So if you're making the decision about whether to buy one of these devices, you've got to weigh the risks and the rewards. The risks are that you've got to pay $425 for this device. So if you're not comfortable, losing $425, and this isn't for you. But if you're willing to gamble with that amount of money, then you should think about it some more. You also have to provide the power for it. I've seen a range of how much power these consume. Nominally, Helium says that the device consumes 5 watts of power. I've seen online somebody with it plugged into a power meter and consumed 18 watts. And I pulled up my electric bill to see how much I paid per kilowatt hour, and that works. 5 watts works out to $11.39 a year, and 18 watts works out to $41 a year. So, that's what you're looking at to power this each year. What will the rewards be? This gets asked in the Helium Slack channel and the Helium forums all the time, and there's absolutely no way of knowing. You will get some of this Helium cryptocurrency. You don't know exactly how much. It depends on how widely the network is adopted, and you don't know what it's going to be worth. But the allure here is the success of other cryptocurrencies, particularly Bitcoin. So I looked up, if you had invested in Bitcoin at the stage that Helium is at right now, how much would you have made? So Helium launched 9 months ago, and I found when I looked this up that the first Bitcoin transaction took place in January of 2009. The earliest price quote I could find was 18 months later in July 2010, and that was 1 Bitcoin sold for 9 cents. On Sunday, when I looked up the price of Bitcoin, it was $9,378.75 per Bitcoin. So if you had invested in Bitcoin in July 2010, you would have increased your investment by 104,208 times. That is a return of over 10 million%. So that's the allure for getting in early here. And the investing in Bitcoin isn't really the best analogy here. A better analogy is mining Bitcoin back in 2010. If you had bought a computer and set up the Bitcoin software and started mining it, you would have mined a significant amount because not too many people were doing it. Of course, it's nearly impossible right now for an individual to mine Bitcoin because you're competing with VC-funded data centers that have enormous computing power and win the race to solve the puzzle that results in a Bitcoin reward now. But if you had started, with just a PC back in 2010, you probably would have mined quite a few, and that probably would have paid off for you right now. So the allure here is to get in at this early stage, pay this $400 or $500, and start mining, getting those Helium cryptocurrency rewards, and build a pretty big pile of that, and then watch the network take off and the value of those Helium tokens increase. So where is Helium right now? They launched nationwide last October. So it's been about 9 months. In that time, as of this morning, 4,214 hotspots have been deployed in 1,000 cities. This is basically restricted to the United States, or they did launch in Canada a few weeks ago. You can see in the figure on the left, they've got pretty good coverage throughout the country. The figure on the right shows the greater New Haven area, and you can see there's 5 hotspots there, and there's 1 in New Haven proper, and that's hanging out in the Westville neighborhood. How is the Helium cryptocurrency doing? Well, it's traded on a couple of minor exchanges, and I want to be clear that I'm not endorsing these exchanges. I don't know that much about crypto, but I have read that these exchanges may be a little dodgy, and some people may have lost their money when they've tried to trade on them. But that said, you can see that the Helium token is trading for 30-something cents today. Yesterday it was up in the 40s. Sunday it was also in the 30s. Last week it was in the 20s. It's new. It's volatile. Even Bitcoin, the price is pretty volatile. So that's what you'll be getting into if you make the leap and buy this device and set it up. And also Helium is a new company. This is a very new technology. I think you could probably say that blockchain, and this is a form of blockchain, is kind of mature right now. There's a lot of blockchains out there, but Helium is doing things with blockchain that nobody else has done before. So there's some risk there. And that's something you have to keep in mind as you decide whether you want to purchase one of these devices. So those are the basics. I've tried in these first few minutes to give you an idea of the fundamentals of what Helium is trying to do, and the basic information that you'd need to think about whether you wanted to buy a hotspot and deploy it and add network coverage to New Haven or wherever you live. I'm happy to talk about the technical aspects of this, but I decided that I'd hold off on that and let that be driven by questions that you might want to ask. So I think I'll open up to questions right now, and I'm happy to talk more about the Helium blockchain, about how the network works, about how you earn cryptocurrency, and any other tech questions you have about Helium.
Great. And for folks that don't want to unmute, you can unmute and speak or ask questions, or you can put it in the comments and I will relay the question to John. So feel free to jump in, anyone.
Yeah, my name's Harlan Christofferson from SITREP, and I guess I have a practical use case here, and I'm wondering how Helium would benefit, or compete against what we're currently doing. So we have a bunch of commercial furnace monitors and devices that calculate the BTU of solar water heat provided from solar water heaters on buildings. And what we have a mix of ways of getting the information to our servers. Some devices send texts over a 4G network. We build up information, create a couple of text packets periodically through the day, and just send ASCII data out and decode it on our end to figure out what the message is, because it's a lot less expensive sending a text at a wholesale rate than it is using a data connection. And then we have some instances where we have Xfinity accounts, business accounts, and we make our own little router gateway to an Xfinity box over Wi-Fi. So you have on one side of it all of our Wi-Fi devices in a building connecting to our Wi-Fi device. We do a bridge to another Wi-Fi device that we've made to get onto the Xfinity network onto our account, because Xfinity has residential and business routers all over the place, and we just use our account on that to get the data when we're in a building and we just don't have a good 4G signal.
So Harlan, I just want to make sure that we get, so the question really is, how does this compete with other technologies that are already implemented?
Yeah, how does it compare? Where is the benefit? Because like in a situation like ours, if we already have an implementation and Helium sounds like an interesting solution, if it can kind of broaden our scope in an area. But I'm just wondering, how is it better? How would it be better than what we're already doing?
John?
Sure. It depends on the costs of what you're doing right now. If your Xfinity connection is something you're using for other purposes, for data, that's how you connect your computers, your phones, then I guess you're essentially getting that for free. So it's tough to compete with free. The data costs of Helium are, for each 24-byte packet you send, it costs 1/1000th of a penny. Or put another way, Helium considers a packet 24 bytes. So put another way, for $1 you can send 100,000 packets of 24 bytes. And Helium states that this will never change. This will never go up. And I guess another consideration is what kind of signal propagation you're going to get where you are. If you're doing, so you said these are for solar hot water heaters? Is that right, Harlan? Well, let me assume that was right. So solar hot water heaters are going to be outside, so you'll probably get good signal propagation. And if you have hotspots, you know, within range, and that can be, you know, a minimum of a quarter mile, and easily a mile, depending on, you know, what the built environment around you is, then you're going to get a reasonably inexpensive data connection, and one that's easy, you know, not that difficult to set up. You would also have to know whether the devices for monitoring these, the LoRa devices for these, are available.
Okay, I guess I lost my connection when you started talking, so I have no. I just picked up the very last part of your conversation. Yeah.
So it will be recorded as well, so it'll be available. I think I have a bunch of questions in the queue about from some other folks. So I think I'm going to jump on there, and we can return to this at the end if there's time. There's a question about, is there outdoor mounting for the antennas and for the poles?
Yeah, that's so the hotspot itself comes with an antenna, and you might have seen it in that picture of the hotspot sitting on a table. But you can add antennas to it to get better transmission, better reception, better signal coverage. There are a variety of them, and you know, different. There was a discussion of these that I've been following. You can get a $15 antenna, which you can stick in your window, right? And up at the top of your window, you're going to get better reception than on the table by the window. There's a $40 antenna, which is 4 feet long, and you can run a cable up to your roof and attach it to your chimney, something like that. With MakeHaven, with JR, they already have an antenna farm on the roof of their 4-story building. So we're talking about, getting a serious solid antenna up there on the roof and running a cable down to their facilities in the basement. So the answer is yes, you can add an aftermarket antenna to this.
Yeah, and the next question is, do the hotspots that are around New Haven talk to each other?
I do not think so. You can see there are a lot of monitoring tools that are available, and the connection data is public. Those are too far out of range. And an obvious question is, what is the range? I addressed that a minute ago, and it does depend what's around you. A mile is not crazy. I'm in a pretty dense neighborhood. I don't expect to get a mile. I think a quarter to a half mile would be better. The higher you are, the better you are. The LoRa folks, every once in a while, they try to do a publicity trick, a publicity stunt, and they'll put a LoRa-enabled GPS tracker up in a balloon. And they most recently did this in April, and the tracker, sent its location, and then they watch where the signal gets picked up, and they set a new record of 517 miles. So in free space, this signal can propagate a long, long way.
And so how much bandwidth will the device consume when the Helium network becomes more popular?
Yeah, the estimates right now are around 5 kilobits per second on average. That may be a little high, and right now there's not a lot of data flowing through the Helium network. There's a few devices out there, but they're in the build-out phase right now. The data that the Helium devices use are it comes from firmware updates. It comes from downloading the blockchain. The Helium folks are working on decreasing the data requirements for downloading the blockchain. That'll speed the setup times. The estimates I've seen is 5 kilobytes per second. I think if you have a standard broadband connection, you're probably getting 5 megabytes per second, which means that the Helium on average is taking up 0.1% of your bandwidth.
And the next question is from Rich. And does Xfinity, Comcast accept this at no charge? Are you going to run into a problem with your ISP because you're providing data services?
Yeah, I don't have an answer to that question. Maybe Travis, can you address that?
Yes, absolutely. Hello, my name is Travis. I'm just a quick intro. I'm developer growth lead over at Helium Systems. If you have any technical questions here, I'd like to be able to address them. A few things discussed here as far as the kilobytes, kilobits. When we're talking about data rate on LoRaWAN, that's something that just shoot the question if you can restate for me real quick.
I forgot it. It was.
All right.
Well, the question
JR?
is right now whether Xfinity will charge, in the future would charge, to provide this type of service to Helium. Right now, obviously, they don't know about it, but in the future they might,
I'd like to pop in on that question. Like right now, my internet service is not commercial. And if we hook up this system, we are in effect becoming commercial. We're making money on it. And so how is Xfinity going to like converting my home and Wi-Fi into providing commercial service? Seems to me like that's got to be worked out. It's
a good question.
Yep.
It's a good question, but the way you think about this, or the way I think about this, just by using chat services such as Google Meet, that we're using right now, this is effectively running servers on your home ISP, right? And so, if you look at the actual terms of service for most ISPs, almost every client application that you're running on your computer is violating that terms of service. A lot of these are outdated. I can't really speak as to whether this is going to officially violate that on your end. But anything that is using a peer-to-peer type architecture is in violation of what most major ISPs. So you can't use, Telegram, most of your messaging apps that I'm sure most of you have loaded up right now. So,
yeah, but message apps, when you're running those, you're not making money on it. I'm not talking about peer-to-peer. I'm talking about making money on the back of Xfinity. How are they going to react to that? That should be known.
So Rich,
I've got.
I think we should probably move on to other questions. Just because I don't think there's an answer to this one unless Travis has one, but so that's
we can move on.
Yeah, great. So somebody asked for a little clarification about how the token economies work and the data credits and seeing that the Helium was capped at 5 million per month, and Bitcoin's different. So I think there's just a little bit of confusion, or maybe additional clarification being requested about the economy of the cryptocurrency and what makes this one unique.
Yeah, that is a very involved topic, and I'll do my best to answer it briefly and clearly. Users of the network who use it to connect devices pay for that connectivity not in dollars, not in Helium tokens, but in something called data credits. One data credit buys you one packet. That's the 24 bytes, and that's what costs, and a data credit costs 1/1000th of a cent. And when data credits can only be purchased with Helium tokens. So that's the story with data credits. Now, the token economics are a very interesting model, and that the explanation requires the knowledge of the laws of supply and demand of economics. So the Helium system is set up so that it generates approximately 5 million Helium tokens per month, and that's fixed. And the usage of the Helium tokens will depend on the uses of the network. I think somebody's typing, and maybe you could go on mute. So when the system is at equilibrium, 5 million tokens are getting burned to generate the data credits necessary to pass the data. If the use of the network increases from that, then more than 5 million tokens will be burned, although only 5 million tokens will still be generated. This means there will be fewer tokens overall. This means the supply of tokens has decreased, and therefore the price will increase. Okay, and that's how the increased usage of the network, the increased popularity of the network, will drive the price of the tokens higher and result in a greater return on your investment in the hotspot. Once the price of the tokens has increased, a token will then purchase more data credits, and so the number of tokens burned in purchasing data credits every month will return to equilibrium, return to the 5 million that are generated. So that's the best I can do on that one quickly and simply. Travis,
Yeah,
how did I do on that, Travis?
Well, to a degree, I think you got a couple things right. I believe that data credits, I don't mean to be rude, but data credits, yes, they are fixed, and there's no speculation involved in what you're going to pay to transmit data over the network. Now, as far as being able to, convert data credits, if I want to buy data credits, that's something that as a company, I really don't have to get involved in any of the blockchain aspect of this. If I just want to use this as a network that's rolled out across the U.S. and and moving into other countries right now, I can absolutely do that. And that's something that we've we're moving forward with, being able to allow companies to roll out onto this platform without dealing with the speculative aspect of anything having to do with blockchain. This is a fixed price that I pay for a data credit. This is how much I pay to send this much information over the network, and this is the kind of coverage that I can expect that Helium provides. So.
Great. Well, and we have a number of more questions to go through, and I know, John, you. So one question I'll add, just for clarification, is so we have the one hotspot in New Haven proper, and I know you did an analysis or worked with Helium to do an analysis about what it would take to get full coverage. Do you want to talk just a little bit about that and how that might lead to the call to action to put up these spots?
Yeah, about a year ago, Helium helped us out as we were trying to do the street sign project to estimate how many hotspots would have to be deployed in New Haven to get coverage. And their estimate was that, we wouldn't cover every square inch of New Haven, but 9 hotspots would cover just about most of it. And the assumption there was that those 9 hotspots would be placed, around New Haven, not all in one area, and also that they'd only be in the first floor window. So we weren't talking about putting up 20-foot antennas on high rooftops.
Great. And so we could obviously increase the performance with greater density or better placement.
Yeah. Yeah. Now, hang on just one second. So I want to give the hard share guys a chance to do this, and I'm thinking that maybe we'll continue with questions until 1:50, and then give the hard share guys the last 10 minutes so that they can talk about their project, which is related to makers and IoT and Helium.
Great.
Sound good, Joe? Yeah. Okay.
I'll try and keep pace with them. So the next question is from somebody who is working on a health project in Canada and would be interested in uses for health situations which haven't already been mentioned. So,
okay. Let's see. So, I don't know, health data is like any other kind of data. It can be transmitted. It sort of depends. I talked at the beginning that I was involved, that I was the co-founder and CEO of a startup that connected blood glucose meters to the web. Obviously, that's you know, a 3-digit number, 2 or 3-digit number, 8 or 9 times a day at most. So that's not a lot. If you were talking about you know, an EKG, that wouldn't be appropriate for this. And also, you also have to know that transmissions using LoRa are not guaranteed to go through. So if you have two signals hitting a LoRa gateway at the same time, there's going to be a collision, and they're not going to get through. I believe that the transmission success rate is in the mid to high 90s. But if you're looking at critical health data, this might not be the connectivity option for you.
And so the next question was about installation. And are there options that are weatherproof so they can be installed outside without having to run lines to an antenna if you want to put it up high?
So there is only one Helium device right now. It is the Helium hotspot, and that is an indoor device. That said, Helium intends to open source the hardware technology so that you could build one your own, or so that others could design and sell these devices as well.
May I step in just for a second here?
Mm-hmm.
No, we absolutely support third-party gateways. If you have a LoRaWAN gateway, you can put that on the Helium network. If you have a multi-tech gateway, if you have a layered, if you have a rack, you know, on a Raspberry Pi, you can absolutely throw that onto the Helium network and just use a packet forwarder that we're LoRaWAN compatible with third-party gateways and devices. And so you absolutely do not have to use the Helium hardware for this. We also support Dockerized containers for the miner to run on AWS or on other, anything that'll run a Dockerized container in the cloud. So I just wanted to clarify that.
Thanks, Travis. So it sounds like those third-party gateways would mine the Helium tokens?
That's something that we are currently rolling out right now. Right now, they act as these third-party gateways that I want to put on the Helium network. They act as packet forwarding devices, but they do not actually exist on the blockchain. That's something that we're actively testing and will be out shortly. And we have a pretty active community. If this is something that you're interested in, using third-party gateways on the Helium network, let's chat. It's happening imminently.
And so I have a question about security risk to your Wi-Fi home network by opening it up to the wider set of devices communicating with it.
Yeah, I have a reference on that, and I'm going to drop that into the chat if I can find it. And while I'm trying that, maybe Travis, do you think you could speak to that?
This is the link. I think we chatted about this what earlier this morning. As far as running this on your network, these devices, these end nodes that are connecting to these hotspots are not IP devices, right? And so there are different mechanisms that you can use to secure your local network, but there's really not a security risk on these. It's I guess what you're opening up your network to is not just it's not outside attackers. It's not you have 2 ports effectively that are used with the Helium hotspot to talk to the outside world.
Yeah. And then we have a question which is about the antenna, and the Helium is 1.5 dBi. Can they share, is there data about the range in low-rise residential industrial mixed 2 or 3 story? So I think this is, I'll summarize the question is there data about the range in different types of environments and conditions? And I believe there was even a tool online for calculating this, right?
Yeah, the tool I'm familiar with it's not a Helium tool. It's there's an open source radio propagation emulator. I think it's called rfcloud.com, and you can drop in your location and the specs of your transmitter, and then see on a map how far the signal's going to go. Let me see. Is that what you were looking for there? There is, the Helium Slack is open. There is an antennas channel. Questions get answered quickly, and they know a lot more about antennas than I do.
So Ryan asks, if he has a device with the dev kit, and he buys data tokens on the internet, does he buy data tokens on the internet to connect to one of these hotspots? So I guess, say we get a receiving device to deploy in the field, how do we physically, how's it work?
Yeah, well, you would have to register it with the Helium network so that the Helium system knows where to send the data once it has received it. At the moment, data credits have not been implemented, so using the network is free, but the rollout of the data credits is imminent, so that's not going to last too much longer. To directly answer the questions, you would set your device up on the Helium network and get it transmitting right now. And if it's within range of a hotspot, then you'll see the data coming in on whatever platform or utility you use to view it. And once the data credits are launched, then you'll have to purchase some and pay for the data as you transmit it.
And this might be our last question before we break to some of the other discussion. But Jay asks about the range that we're anticipating and concerns about access if we are deploying this, and then something about refund credits. But I'll just put the question out there. So if we, on this call, number of people buy these hotspots individually, we're not going to necessarily cover the full city. And so do you have any thoughts on how we get full distribution, or what the challenges might be around making sure this is deployed citywide?
Well, I think that let's get it started, and then let's tell people about it, right? I think that's the way to make it happen. And I think what we can make known is that this is a relatively simple solution to deploy, and that it does, once you get it deployed, you do start earning tokens, and that once people are convinced that the more hotspots we have around here, the better, then once we get that word out, we'll begin to fill in the gaps.
Yeah, and I think there's one more question I'll ask before we jump over to the other group. And is Helium open source? And yeah, what about the open sourceness of the Helium technology? And I would say the ability to, say, use the Helium hotspot for something else if ever necessary in the future.
Hit our GitHub. It's based on Raspberry Pis. Yeah, if you want to repurpose it, you can yank it apart and use it for any other Raspberry Pi type project you want. But on the previous question, as far as when you're Cloud RF actually is the site that's very good, that allows you to overlay topo maps on top of radio maps, and so you can see very, very close and very accurate radio propagation maps. If you're talking about a layout, when you're thinking about civic type of projects, if you look at locations like fire departments, firehouses tend to be geographically kind of spread out for the same reason that you want to spread radio out, right? So do bus stations. And so when you start thinking about like, civic entities like this, that's a good way to start kind of approaching radio layout, right?
Great. Well, I think we can return to questions after, but I believe that Joe, there's some other guys that had their project to talk about that's related.
Yeah, we've got Joe and Chris and Drew, and I am going to bring the presentation back up because I have a couple of slides for them, and they're going to tell us about a platform they're setting up to make it easy to develop IoT devices, and this platform is called HardShare.
Yeah, so Drew, Joe, I'll do a quick introduction myself, and then talk about Makerspace CT and what we're doing over there, if that sounds good.
Excellent.
Cool. So I'm Chris Meyer. I'm the co-founder of HardShare with my partner Scott Livingston. I'm not sure if he's on the call or not, but Scott, if you're here, feel free to jump in if I say something wrong here. But when the pandemic really hit, one of the things that we noticed was it's really difficult for people when they're working from home to not only work on embedded hardware, but also collaborate and make sure that the problem doesn't exist between the keyboard and share. So what we created was HardShare. So in essence, it's a hardware as a service platform that offers the ability to connect to a sandbox environment with an embedded device. And in this case, what we have is the ST Micro Discovery Board. That's what you're looking at over there on the left. We've got an array of them that you can request an instance with, and then you have a code editor that you can submit your code and deploy to it. So John, if you can go to the next slide here. But in essence, what you're looking at here is actually what we have installed at the Makerspace CT, which is an array of the LilyGo TTGo devices that have an OLED attached to them. And I'll drop a little link into chat here where anybody can go and take a look at this. But for anybody that doesn't have access to a hotspot or doesn't have access to a developer board, what this is going to enable you to do is you can build out your entire application, soup to nuts, as they say, without having anything more than a browser. So you can take the sample code that we have there, build out the device to send packets across the Helium network, plug in your app EUI, dev EUI, and app keys, and then see your data traverse the Helium network and then backhauled to whatever service provider that you want. In that little tutorial that I put there, they have instructions on how to do that with AWS IoT. So yeah, it's probably the easiest way to get started with Helium, because the sample code's there. All you have to do is create your keys in the Helium console, and then you're off to the races, making mistakes and trying to beat your head against the keyboard on your own time instead of waiting for hardware and hotspots to do that.
How much does one of those development kits cost?
So the ST Micro Discovery Board, I believe, are $50, Travis, on DigiKey.
Every Wednesday at 3 p.m. Pacific time, if you drop into the Helium Hacks Happy Hour, I will give you a developer kit if you give me an interesting idea. But it'll cost you about $75 if you want the MEMS sensor board the shield that sits on top of the ST Micro. But you can get these boards that we're looking at in the picture right here for $11.
Yep.
Wait a minute, quick question. Does that board have GPIO pins on it?
The LilyGo does,
yes. Yeah, and it's so maybe I'll go ahead and jump in. Is that
please,
okay?
Joe? Yeah.
All right. So I'm Joe, and I guess my camera's not running, but I'm going to flip this around. 1 second. Oh, sorry, I have to start the camera first. That's why. Haha. Apologies. So the question about getting access, it's not just buying the development kit, it's also buying a gateway if you're not in a city that has a gateway. So, this was one of the reasons that Chris and his crew came up with the concept. We think it's a great idea. So we're sort of, we're buying into it, so to speak. This, if you guys can see if you unpin John for a minute and go to my video feed for those listening, you can actually see the live version of the HardShare instance running at our space at Makerspace CT in Hartford. And the beauty is you can sort of log in and get access to this, not have to have a hotspot, not have to have the dev kit, and you're ready to roll.
Yeah, so this offers the ability to test out, how your application might work on Helium. And at least then you don't have to, we have a friend that has to drive out about 45 minutes to sit in his car to test out his application about once a week. So you can save yourself a trip in a hot tin box.
So these devices that we're looking at now are a way of getting a signal from your sensors into the hotspot to hop onto the network to be received someplace.
Right. So if you wanted to actually really, it's not just a simulation of flying a packet on the Helium network. It is actually flying a packet. So you'd build the application, in the window. You'd upload it. It would actually be flashed to an actual board, and the radio would actually send a message to an actual hotspot. So it's sort of it's a remote access to a real system. It's not a simulator. It's a real system.
Yeah. And that was the big point of HardShare, is enabling people to, work from home, but still be productive and disambiguate issues with hardware, software development environments, physical environment into something to where you can meaningfully collaborate on IoT projects, embedded systems, and stuff like that. I actually have NVIDIA TX2 connected to this. I've got I've got a beer coaster that we built that has a temperature and pressure sensor, where you can distribute beer coasters at a brewery and see like how much people are drinking when.
That's beer pressure, not peer pressure, right?
So yeah, beer pressure.
So if I understood correctly, the coding development environment for these little guys is web-based, and if that's true, what programming languages are they supporting?
Well, it depends on the board.
These boards are programmed in Arduino. Chris and his friends have set up a system by which any board that is compatible with Platformio should work with their system. We selected these boards, frankly, because it was inexpensive to get a bunch of them and tie them all up at once. But I write my code in Visual Studio Code or in the Arduino IDE and copy and paste it over the web browser to flash it. You can also just write, if you're writing simple code, you can write it straight up in the web browser.
Thank you.
So I know we're coming up on the hour, and I wanted to throw in quickly that there's probably some more events that are going to happen, both Makerspace CT and MakeHaven. So anyone that's really interested in this should stay tuned to whichever channel they kind of came in on, because there's definitely more coming. And with that, I'll throw back to John, I guess, or JR, or somebody.
Sure. Well, I think there's a question for you guys about if you are doing this as a service to use the hardware, or if you're just designing something to put out there.
So we're still working through how we want to do this, but right now it's a service for it's more of a B2B service. We're thinking in the longer term to offer individual access to a variety of boards, to where you can have a subscription and have all the stuff that we host individually. In this case, Makerspace CT is just fantastic to work with, and so we're helping them leverage their programs that they're teaching, and frankly, with the limit of having 50% capacity, in-person classes become very cumbersome, and that's where we're helping them be able to offer those as part of their service. But
yeah,
short term, it's B2B. Long term, maybe B2C.
It's sort of an ideal environment for education. Sorry, I've got my mask on. There's no need for that. It's sort of an ideal system for education, and also potentially for a company that's trying to roll out an application if their employees are at home, et cetera. So we see a lot of applications for it. We're going to be pushing pretty hard over the next few weeks. So if anyone wants to play, keep our number.
Yeah, and reach out to me. It's just Chris@rerobots.net. I'll drop that in the chat here as well. The bigger vision is continuous integration for firmware and embedded systems. To be able to have this part of your continuous integration development that utilizes hardware, I think is gonna really change a lot of the stuff that I don't know about anybody else, but we've had to build at Misty Robotics in particular. We had to build a lot of these systems ourselves, and it worked at my desk, I swear. I'm sure anybody that's dealt with these types of devices has had that situation happen to them.
So, one thing, Chris, I'd like to tag on to that, if you don't mind, is
please.
Because ISM radio bands are different in different countries. It allows people from different countries to actually develop on the Helium network to get this, to test this out, to see all of the data coming through all the way up to AWS, to Azure, to IBM Bluemix, whatnot, and still abide by their RF radio guidelines in their own country, right? They're not breaking the law here, and so I think that's a huge advantage. And I've got to do this plug. Helium is currently running a contest with a lot of cash to give away and hotspots to give away on Hackster.io. It's called the IoT for Good project. If you check that out, I'd love to chat more about ideas over there.
That's great, and that works well with makerspaces in general, in that we're often working to host various brainstorming ideation sessions to motivate and inspire our members to create some new prototypes and explore these types of technologies. In fact, I'll do a shout out we have there's a civic related hackathon about making cities more resilient to disasters and any innovations that can come around that, including pandemics. That's coming on Thursday this week. And then in the following week, there'll be another ideation session around mobility and how we use technology to help with various mobility problems that cities have. So those would be good places to use the Internet of Things, Helium technology as part of a solution you propose. Well, great. So, John, we're at the end of the hour, and we can keep talking, but I think it might be a good moment for, if you have a close where there's you're calling people to volunteer to buy these. Are we going to try and do it as a group and make a group order, or are we going to continue the conversation? What are your closing remarks?
Yeah, I think that is a great idea, JR, that if you are interested, if you're sold on this and you'd like to form a group with us to make a group purchase, a bulk purchase, and then keep in touch as we deploy these and begin to use the Helium network. I think maybe JR, you can send a follow-up email and we can solicit interest and take it from there.
Absolutely, yeah. John and I quickly threw up just a Google form where you can put some information about where you're located and if you're willing to do it and if there's any barriers. So, perhaps we'll be able to find some ways to reduce the costs. And if we have an idea of where those are distributed, that will help us. So it's makehaven.org/IoT-network. I'll share this via email. And once we get that data and we know how many folks we have that are serious about this in New Haven, we'll use that as a jumping off point to take it further and fill in gaps. So take a moment to fill it out.
Great. I'm willing to hang out and answer the rest of the questions in the chat, or any questions that anybody wants to ask audibly, and I'll stay as long as you will.
Yeah, we can stick around too for a bit if anybody has questions about our instance of HardShare. And I think before we kind of got wrapped up in what we got wrapped up in, we were going to mention that I have a Helium hotspot at my apartment currently. It is ostensibly property of Makerspace CT, but we are in a bunker at Makerspace CT, so it was decided that that was a poor place to actually deploy it. So we're kind of figuring out how to juggle that. But thanks everybody, and we'll stick around for the after party here.
Great. Well, and thank you everyone for coming. Great. So other questions. So there was somebody was asking when you were talking earlier about code and GitHub, about what that was about. And as I think was clarified in the chat, but for the benefit of everyone, those are for folks that are looking to implement their own hardware as an alternative to the Helium hotspot. The Helium hotspot itself is, to my understanding, although I haven't done it, very plug and play, very easy, and does not require coding. So that shouldn't be a barrier. And although we've been diving into some of the technical elements, you only need to open that hood if you desire. Great. Other questions, folks? Free form.
Did we get to all the questions in the chat, JR?
I believe that we got to the core of all the questions. There's some that I paraphrased.
Yeah, and I was throwing in text answers as well. You know, somebody was asking about range, and it's worth pointing out that I've experienced less range than advertised in urban circumstances. So with that gateway, which is approximately 25 feet off the ground, you're looking at maybe a 1,500 foot radius or less, depending on your end node device. You know, not miles in an urban environment. So that's a thing.
No, that's very good to be spoken and to have out in the open. But if you have line of sight, you can hit a satellite, right? You know, with one of these end nodes, and that's something that people have to understand, that there's a lot of voodoo that goes into radio, and there are a lot of elements that I can't just say this is how many miles in a city that this technology is going to go between a node and a hotspot. It's ridiculous to you know, to take it to that type of conversation. I mean, you have numbers like RSSI, signal to noise ratio. I mean, yes, is it a very effective? Is it does it work well through like concrete and even steel building materials? Like you know, more than like 2.4 gig or 5 gig. The technologies, yeah. And so you're going to have more propagation there. And so, but you can't just say, yes, this will go 5 miles. And that's why we're really trying to bring in real world testing, you know, where you go out and you can, you know, collect this data and pull it together and see, you know, as a community, you know, if you're building this, you know, together locally, you can see what type of real world coverage you're getting out of the network. And that's why I think it's important to have, you know, these patron programs and, you know, companies and individuals coming together to work on projects like this. So 2 cents, you know, if you're on Slack, if you have any questions, please hit me up. As far as Helium, we have the developer section over on the Helium website, and we have extensive documentation about everything that I've mentioned today. So, you know, please come check it out.
Great. Well, thank you. Jay asks about deployment efforts in Hartford, and is there a benefit in a multi-city effort where both New Haven and Hartford are now deploying these networks simultaneously?
Well, I think there's definitely a multi-city benefit to that, and we should try, and we shouldn't stop with just those 2 cities. We should also be talking to Bridgeport, Stamford, Waterbury, Watertown, and the New London, Groton area. I've looked at the map. I think there are a few more in the Hartford area than there are in New Haven, but Joe's in Hartford, he'd know better than I do.
Yeah, I think there's not continuity of service yet, so you're not going to get an end node to hit multiple access points or gateways, hotspots. So that was an experiment I tried recently, just a few weeks ago. I actually drove down to Stonington and was able to get an end node to broadcast a packet, which was simultaneously received by 3 different gateways. Currently, I don't think there's a spot you could stand. Maybe if you stand on a top of a building between downtown and just slightly northwest of downtown is another one. So if anyone really wants to stalk me, you can go find Early Hemp Corgi. That's the one in my apartment, and there are others in Hartford as well. But it's not at all a sure thing to have an end node that would hit multiple gateways. But yeah, just to reiterate what John said, I think it's absolutely, it's a value. Oh, that's true. Sorry, I got some echo there. It's a value to lots of different stakeholders for the state to be well covered. So, John and I initially talked about trying to figure out the most efficient way to get excellent coverage along the 95, 91, 84 corridors, because, lots of stuff follows streets. That's an unfortunate reality in many ways, but it's a reality. And if you have an application that you think is interesting that would benefit from coverage that doesn't necessarily follow streets, it's us or Travis or John. Hit up whoever invited you, so to speak, and we'll get it all figured out.
I know as one example that in talking to some folks from Yukon, they have a trail data project where they are collecting data on trails, and they're doing them with SD cards, and they go out and have staff picking up all this data all over the place. And what they want to do is actually increase the density in urban areas and for trails and hiking that's happening in proximity to cities. But they struggle with the ability to go and pick up all the cards, and then after 6 months, they figure out the card's corrupt or there's a problem. They lose a lot of data.
The sneaker net of things.
Yeah. So this is this sort of technology. You start implementing it widely between the 2 cities, and we can start getting the attention of these statewide type initiatives because they're a consumer of this sort of larger data.
And I will add to that I am also in the midst of starting a pretty active push for deployment in Eastern Connecticut, New London County as well, where there have been a handful of new hotspots that have popped up over the last month or so.
I have a couple of technical questions. Should I wait until after this is over, or do you want to hear them now?
No, I think we're in the free form. I was trying to keep it moving in the more formal session, but
all right,
everybody's getting their voice.
Let me pop these couple of questions at you. So let's say we have a device that is broadcasting a small packet of information to a hotspot. And if all goes well, the hotspot relays it onto the internet to a destination. And but if the device that sends that packet of information, it has no way of knowing if there was a success in reaching its destination. Is that correct?
You can request acknowledgments on packets, so you can request an ACK.
Oh, okay. So and then the next thing is, what happens if 3 hotspots pick up the signal at the same time? Do they all repeat that same packet 3 times up onto the larger network?
Right now, yes, and for certain use cases, that's something that you want. If I'm wanting to do something like trilateration, or a lot of people get this confused with triangulation, but trilateration is where I can use radio signals and to determine a location without using a high-powered device like a GPS, right? And so in situations like that, I would want to use as many hotspots or gateways as actually pick up this node signal, right? But the thing is with the Helium network, because you're actually paying each hotspot that relays the data, you may only want to, pay for this to be relayed through, I guess, the strongest signal provider, right?
Okay.
Does that make sense?
Yeah, but that's
yeah, because
that would,
you don't want to pay 3 times. Someone doesn't
Right.
want to pay the cost of 3 transmissions. So up at the top end, someone has to be aggregating all those signals and deciding, well, these 3 are the same, so we'll just knock it down to 1, and that one person, whoever that came from, gets the money, right?
Or I mean, we say, okay, whoever's first, right? I mean, whoever provides me transit. Right. But if I lose my kid and I've got a tracker on my kid, then maybe I do want, to get, I don't mind paying 10 cents in order to get, receipts from all of the different hotspots, right? And so I believe there are use cases where that can be absolutely, in your best interest and something that you want to do.
Okay, my last question.
I think Harland was trying to jump in, so I'm going to pause you for a second. Harland, you're trying to jump in?
Yeah, I think I kind of thought through the answer myself. So I mean, it's not like Wi-Fi where you have an SSID and then you have hidden SSIDs where you can force yourself to connect to a particular hotspot or not based on whatever atmospheric changes give you a stronger signal. You're just connecting to whatever is around you blindly without any control.
Right,
yeah,
right.
The simplest.
Go ahead.
No, go ahead, Travis. This is dumb for me to answer. You answer that one.
Well, an in device is not associated with any type of gateway or hotspot. It's associated with a backend application, right? And so anything that is, that listens, that picks this up, especially in the case of not using acknowledgements, then it's just kind of fire and forget, right? And so any hotspot that does pick that up will relay, and then it's kind of on the other end on what gets picked up and what gets relayed over. If you get it, I mean, play around with it. Get an account on console.helium.com, and you can see rows for every gateway that's picked up every packet that you transmit. And you can see your RSSI, your signal to noise. You can see all this data as it comes through. We have a debug panel, so you can see these payloads as they come in live. Just play around. It's free. Just play around with it.
So and we have. Well, let me. Yeah. So we have another question about data credits and integrating. So who's going to run the purchase of data credits, the system? When are data credits launching? Is the credits currency integrated with Helium somehow?
Okay, HNT is the cryptocurrency that is mined on the Helium network. That is that's something that could be speculative, but data credits are fixed, and so you pay a fixed amount of US dollars to transmit this many bytes over the network. Period.
Would you assimilate that to gas, Ethereum gas?
I can't speak to that.
Okay.
Who gets that money?
The hotspots that are relaying the data, those data packets. That's how you get paid out, right? That's how a hotspot.
You can think of it as a toll, right? That's kind of the easiest analogy is the packet carries with it a little package of value that gets handed off as it goes via a gateway. Is that accurate, Travis?
I get paid to relay people's information, right? And they pay into the network, which goes directly down, to hotspot investors and owners, for being part of the network, and not just for data transmission, but for proof of coverage on the network. For right. Okay.
So, but I guess my question is, who's that central authority that's taking my credit card and issuing my credits and then distributing that money?
Or like, how do we get them too?
Yeah, so you would buy Helium tokens on an exchange somewhere, or you would have generated them yourself as a hotspot owner.
They're separate from DC though.
Separate from what?
DC.
Right. So you need HNT to buy DC. You can get HNT on an exchange, or you can mine them yourself. And then you use the HNT to buy the DC. The HNT disappear; they're not circulated anymore, and they get burned. Yeah, they get burned, and they use the DC, the data credits, to pay for your data transmissions.
And is that exchange going to be a fluctuating value in terms of the DC to HNT?
Helium has nothing to do with this. Helium is completely hands-off on any exchange here. So
I wasn't talking exchange. I'm just talking about DC and asserting hotspots.
I'm sorry.
Obtaining DC.
So you buy DC, you pay for them with HNT, the Helium token, and that happens on chain, right, Travis?
In the app.
Yeah.
Well, that's something that there are exchanges right now that are currently trading HNT and allow you to
the purchase of the data credits.
Yes. Yes.
Do you purchase the data credits from a hotspot specifically? Like who is issuing the data credits?
The data credits, they are not in play at this point. Right now, we're still in beta mode, and so the DCs are completely free. There's no cost to use the network.
Many blessings.
Meaning what?
Many blessings.
Okay. But that's something that is very, very quickly going to be put into play, and which is good, which also means that hotspot owners will be paid to relay this data, and so we're going to be moving over to a system where you're not necessarily earning as much by proving network coverage, but by actually doing something on the network, by actually relaying data. And so that's why when we start looking at use cases and where these hotspots should best be located, we want that data to be moving through our hotspots, because that's what allows you to earn Helium tokens, right?
Yeah.
Is there a way?
I think what Chris and Ryan are getting at is who actually sells the data credit. Is that going through the Helium entity? That's not on an exchange? That is just a function of the blockchain?
Correct.
Okay.
Can they be earned or only purchased? DC.
No, HNT may be earned.
Only DC can be purchased with HNT.
Or DC can be purchased only with HNT. You don't buy them with dollars. Yeah.
Got it. Thank you.
Yeah.
That answer your question, Ryan?
Yeah, I guess the answer is it is still a blockchain transaction of it is fully integrated, that there's not going to be some corporation there who's selling the data credits and taking your credit card. It is a blockchain related transaction, or not?
Yeah.
Okay.
That's what as far as I know, that's correct. And that gets into another issue of the governance of Helium. And an organization called the Decentralized Wireless Alliance was recently established to, I don't know if govern is the correct term, to manage the governance and oversee the governance. And there is a GitHub mechanism to propose and comment on Helium improvement proposals, HIPs. So that is the status of Helium governance as I understand it, and it's also something that is being worked out as the functionality of the system gets rolled out.
Thank you.
And just a comment, if you'd like a voice in any of this, we have a very active Slack community. Just jump in, man. And just go to chat.helium.com, grab an account, and there will be people to talk to you over there. So, you know, to field any questions, whatnot.
Somebody was looking for a link to the decentralized network.
I'll find it. Hang on.
Great. Were there any other questions, Rich? I think I paused you. Did you want to do your final question?
All right. Am I on? You guys
You're
can
on.
hear? Oh, okay. So one of the things I'm concerned about, let's say that there's a number of IoT devices and perchance they all try to transmit at the same time. And there is one hotspot in the area. And so what you have is a collision going on. Now that would be, the transmissions are so short, it would be a rare event. But they could effectively just drop the whole transmission. Nobody gets through and nobody would know. Is that right?
Well, if I could take this, because it's built around the a chirp protocol, it's very resilient. I mean, you can have very, very noisy radio going on and still have, transmissions get through. Like I mentioned earlier, you can do acknowledgements or request acknowledgements for transmission. You also have, and we haven't touched on this at all on this call, but you have something called spreading factor. And so you have your time on the air, and that directly correlates with effectively the distance and the power that it's going to take, right, for this transmission. If you need a guaranteed receipt on the other end, this may not be the best protocol. You have to look at use cases for what we're talking about here. I mean, if I miss a thermometer coming in from an agricultural sensor, once every 15, I miss a 15-minute increment on that. That's a lot different than missing a heart monitor or missing, something that's life critical. And so it's something that when you're designing systems and IoT systems, you have to realize that. You have to take that into account. So
yeah, it's a safe bet that train operators are not using this technology to decide when to switch tracks. Exactly.
Yeah.
Well, getting to that previous question. So it's not like the IEEE 802.11 that governs Wi-Fi, where you have a protocol where, like, as a user, it's all kind of handled down at the physical layer, where you don't even have to think about transmission, collisions, rebroadcasting, or anything like that. The radios and the protocol embedded in the radios kind of handle that for you in a Wi-Fi situation. So this situation, the radios aren't sophisticated enough to handle the physical layer connectivity issue?
No, actually, no. And that's when I say no, actually the physical layer of LoRa is patented and is closed effectively. And so it's everything sitting on top of that is open, right? And so a lot of these are handled on board. A lot of this transmission is absolutely handled on the physical layer, and that has to do with what we can call duty cycle and dwell time. Duty cycle is used in Europe. Dwell time is something that is basically how much time you can spend on a channel, without hopping around. That's what's used in the United States.
So when you're making an IoT device using this radio chipset, you don't even need to care about that because it's the radio chipset handling it. You're just giving the radio the data that you want to transmit or responding to an interrupt that the radio gives you to receive data. But that actual handshaking, whatever's going on in this patented layer, you don't need to care about that, really.
It kind of depends between different manufacturers. Look up LMIC stack for LoRaWAN, and there's IBM initially came out with LMIC, but there are so many different forks of this and so many different derivatives. If you look up MCCI, it's a company up in New York, who in Syracuse, I want to say, and they have a LMIC version of the library. There's that handles a lot of your radio transmissions. But yeah, absolutely, a lot of this is handled on the hardware layer. And if I try to push something too hot, if I'm trying to run data too fast, then it will just either queue or just kick it or just hold off, right?
Right, but that's kind of like that's a higher level application kind of thing to manage the data flow. It's not, you really are hands off the radio connection and whatever's going on there to maintain that.
Well, like I said, the physical layer is closed, and so you're hands off physical layer. Did that answer your question? I'm sorry.
Well, it answers my assumption. I was just kind of going down a path to Rich's question about collisions and whether or not data gets to somewhere. It sounds like if you send data and you send too much data, it gets queued. Well, but it eventually gets across the radio channel.
There's no.
Yeah, I was thinking of collision detection, multiple access, where the device will sense that there's been a collision and it'll wait and then try again. So when the IoT device sends out a packet, does it ever try to send it a second time?
Yes. You can have multiple sends there, and. I mean, are you asking for an acknowledgement on like for receipt of this?
Well,
that's something that can be done, and that's also what you want to do if you're willing to get like your RSSI or your your signal to noise numbers down for
Yeah, so the acknowledgement is cool. It means it reached its destination, but collision detection, multiple access, nothing reaches its destination. It's just that the transmitting device, the sensor device, just knows that it's unsuccessful in getting a signal out. And so what it does is it waits and tries again. And that doesn't require an acknowledgement. It's just part of the hardware, as we were talking about. So I was just wondering, do these devices keep sending until finally they get it out without detecting a collision? That's all happens at the transmitting device that's trying to get into the hotspot.
I like you, man, and I see what's in the background over there. Man, come into the Slack and check out. I'm working on building a field test device that allows, I guess, for more of this information to be kind of in hand when you're doing testing for signal strength, for relay quality, for some of the numbers like that. I'd love to chat with you on a more extended basis on this conversation here.
Okay, thank you so much, and and I'll just cut it short at this point. All right, back to deck control as the amateur radios people talk.
So, I was going to say quickly, MCCI is Ithaca, and I can't for the life of me remember his name, but we've met him a couple of times, John.
Terry Moore.
Thank you. Yeah, there you go.
Thank you, man.
Well, it appears to me that we may have come to the end of the informal questions. So I think folks should quickly volunteer any burning questions they have now, or I will say we should disband.
Maybe when exactly, or give or take, you think the DC credit assertion is going to be implemented?
Soon. That's above my pay grade. I'm sorry, bud. It's happening very soon, and that's the best I can give you, man.
Fair enough. I appreciate it.
I have a question. I haven't spoken yet. Quick.
Sure.
Just get back with the interference, just a simplified version of the interference. How many units would be so many units in a city that they would no longer function properly? So like 500 units were picking up a dog collar. What would happen there?
Well, there's a few issues at play here. For example, if I'm running 8-channel concentrators, that means that I have 8 channels that are uplink channels. If I actually want to go and send out a downlink, I have to turn off my uplink channels, right? And so that's why downlinks are kind of frowned upon in LoRaWAN implementations, right? There's, as far as dog collar, and I know it's a decent use case. It's just, it comes up all the time, and I don't know. I've got some very strong opinions about that one, but the Things Network claimed in most of their original information that a hotspot can handle about 10,000 in nodes, right? And that's because everything's not hitting at once, you know, and when they do hit, when you do have collisions, then the protocol has been designed to effectively handle that, right? And so I think that number is high, to be quite honest with you, but in a city, it's not just the number of nodes that we're talking about. It's not the number of nodes talking at once. It's the fact that you're having a lot of radio issues that are going on. It's hard to give a straight answer on that.
I think, you know, it's, if you start to imagine the physical density of little sort of not that smart but smart enough devices, 10,000 is a lot. You know,
yeah.
if you're talking about my hotspot has a you know, a catchment area of let's say it's a square mile. It's not, but let's say it is. The 10,000 is, you can start to imagine those distributed over that area. You know, it's, you know, when John Fitzpatrick and I were talking about getting a device that would detect a stop sign being down, our thought was, well, how much traffic do you need to send from this device? And, you know, you probably want to sort of check in once a day, maybe twice a day, to just say, hey, I'm still alive, I exist.
Yeah.
But then after that, you know, if a sign gets knocked down, you could start saying a message every 30 seconds until someone picks it up or something like that. So there's a lot of days, months, years where that thing is just not used that much. And obviously not every application will follow that, but a lot will, right? Like if you've got a moisture detector in your basement, maybe it checks in again twice a day, and most of its job is to just sit there and tell you everything's okay, don't worry about it.
Yeah, or if you have a bad actor who is trying to flood out, I guess, a network, right?
Well, that's a possibility. I mean, I don't know how much we see that with Wi-Fi and cell carriers right now. It's like, yes, it could happen. Does it? No.
Yeah. Well, I mean, up until Helium really rolled out, Wi-Fi, I mean, LoRaWAN really wasn't in use in the States. I mean, it was, I mean, you see private networks, but, you know, I was involved with the Things Network for a number of years, you know, down here in Houston. And I was to the point where I was trying to give people gateways that I had built up and just say, hey, just plug this in, please. And we just didn't see TTN adoption, you know, happening in the States like we did over in Europe. And Helium since what, August, we're in over 4,000. We have, you know, it's ridiculous, the coverage that we've been able to build. And just, you know, and a lot of these, I mean, I see Garvin on the call. I mean, I know a lot of this coverage is because of folks who are really going in there and putting a lot of these hotspots out and, you know, investing into the network. And that's something that, you know, that's why it's the people's network. That's why it's everyone. You know, you run a hotspot in your house, and that builds the network out where you're at. You know, the more people that are near you that can, you know, kind of operate and validate the network off of you, the stronger this network is. You know, and so I think the critical thing now is let's get some data across this, because the coverage is insane. I mean, it's really crazy. And, you know, with like these Oyster GPS trackers, just recently, just driving around town, you know, and looking at some of the data coming through the AWS. There's new hotspots that are just you know, popping up every day. It's cool stuff, guys, or folks. You know, if you are on the fence about Helium, just come over to the Slack. You know, get a console account, check it out. There's a good group of people, some great developers over there. I think that this whole network is moving very quickly, and it allows you to really scale IoT concepts and ideas in a very, very rapid manner. So, and if you have any questions, hit me up. I'm usually online.
I mean, it sounds like a pretty cool concept. I'm just, because we have a lot of IoT things already deployed, I'm kind of like struggling wrapping my head around where, like, the making the economic sense of it all.
Okay, go to helium.com/business, and we have a calculator there where you can run up exactly, you know, how many devices, you know, what type, you know, over a year, and how much you're going to pay, and it's going to shock you. It's low, because you're not paying SIM cards, right? I mean, you're not paying cell fees. You're not paying, I mean, the per device cost is ridiculously low. And we support everything LoRaWAN off the shelf now. So, you know, you're not having to do, you know, custom firmware development if you don't want to. You know, you go to My Devices and you have a list of hundreds and hundreds of off the shelf devices that you can throw into the network immediately, you know? So, just, I mean, if the concern of yours is cost, at least take a look at that.
Harlan, you were bringing up solar earlier, right? Solar hot water systems, I believe. Do I remember that correctly?
Yeah, there's some water recirculation systems around the area, and you know, it's a closed loop system. So water gets forced up to the solar collector, gets hot, comes back down, comes to like this, you know, essentially an exchanger tank.
Yeah.
And people want to know how many BTUs that generates.
So I used to work with Everett Barber. Are you here in Connecticut, or where are you?
Yeah, I'm in Guilford.
Okay, so then you know Everett Barber, obviously.
I mean, I've heard. I've never.
Okay. Yeah. Sorry, carry on.
I mean, for example, if this has any bearing, like this is a Modbus to LoRaWAN bridge, right? And so any system that, you know, supports Modbus or, you know, 485 or RS485, you know, I connect this guy up and this talks over Helium now, right? You know, it allows me to really interact with a lot of industrial interfaces that may already be deployed, SCADA systems, etc. It's easy. It's cheap. It's worth playing with, I think. So.
Yeah, I don't know. I'll check it out, because I mean, what we do is we accumulate data throughout the day, send out a burst to our server, do all the math on our server, and then present it like in a nice web-based GUI for the customer to see what's going on. But because of the cost involved of, you know, blasting data up either through a text or a CAT-M modem, we just do it 4 or 5 times a day. It varies, but.
Well, that's what was kind of brought up. Oh, go ahead.
No, I was just gonna say, Harlan, you know, at the conclusion of this, figure out a way to link up with me. I'll put my email address or something, but I'd love to chat more. I'm sure we know common people.
Okay, sure.
Travis, were you saying something?
Well, it was mentioned earlier in the call about using, you know, micro SD cards in the field, and, you know, having to relay data that way. And I've worked with some companies who are doing wildlife, you know, data collection in Peru, and they really don't like having to walk out to get those cards. So, like I say, the Helium console, it's free. Right now, There's no charge for data credits. You can build. We have instructions on how to build your own DIY hotspot. If you need a development kit, drop into the Helium Hacks happy hour tomorrow. I'll give you a board. I mean, we have this contest going on at Hackster.io. It's really, it couldn't be easier to get involved here. And I want everyone to understand the reason I work for Helium is because I've been involved in LoRaWAN for quite some time now. I run the Greater Houston area Hackster.io meetup group, right? And I told Helium that they needed to give me a job because I wanted to be a part of this. And it's this like Helium, this company is doing what TTN wasn't able to do, what I wasn't able to do with TTN for the past 5 years. This is happening. It's neat. It's neat. And I don't come in from a blockchain perspective, understand, right? I come in from pretty much a pure IoT perspective because I want to see a distributed, people-owned IoT network that we can all write encrypted applications on top of. So that's my spiel. So
well, and thank you very much, Travis, for being here for the long haul.
Thanks for having me, man.
I very much appreciate it, and I'm sure that you are busy. Somebody asked for the transcript for all the links. Yes, I will send an email after this. It'll include the transcript, the YouTube link, and the link to where you can sign up to be part of the New Haven initiative that we will be working on.
And if you guys have questions with Cloud RF or doing like the topo radio mapping, hit me up on that. I can lend a hand there.
Excellent. Well, thank you, Travis, and thank you in particular, John, for pulling this together.
Yeah, great.
Excellent. I look forward to seeing data moving around New Haven.
Thanks, everybody.
Thank you, everybody.
Thank you.
Thank you.
Thanks, everybody.
Thanks, y'all.
So is this where we let everybody else fall off and we have a debrief?